y double prime plus y prime minus 2y. Let's I'm gonna change it up now. 3x squared minus 2x plus 13.
13? It's quadratic, right? The one that you want me to do? Find A, B, and C. So 2a plus 2ax plus b minus 2ax squared minus 2bx minus 2c is equal to 3x squared minus 2x plus 13. Probably would have been more interesting to this up a little bit. That's fine. You can do both. Okay. Did I lose you though? Did I did all that really fast? Okay. Let's start balancing this stuff a little bit. So on the left side I have a negative 2a x squared coupled with a 2a minus 2b x. And finally I have a 2a plus a b minus a 2c. That's equal to my 3x squared minus 2x plus 13. So we have negative 2a is 3, which is why a is negative 3. We have that 2a minus 2b that are equal to negative 2. I just found out a is negative 3 halves. B is now negative 1/2. Going fast. The last one is going to be 2a plus b minus 2c. That has to be 13. But I already know a. I already know b. I just need to find c. So negative 3 plus negative 1/2 minus 2c is 13, which is why negative 6 minus 1 minus 4c is 26. Negative 7 minus 4c is 26. Negative 4c is 33. 26, 46. I think that's right. And then c is negative 33/4. There's your ABC. And just do a lot of those. And you can see the more you do them, the faster you get. So I did this about 3 or 4 times faster than I ever did in class before. But that's because I just wanted to do another example.
So would it be better to have the process memorized for each one, or?
I don't really memorize
or,
this.
Okay. Can we run through one with like sign?
Sure.
Okay. About y prime, double prime.
I would love to do is like make a quick banner and actually run through it. You know, with the sign. Go ahead.
That was not funny.
Ah, well, it's funny if it's funny to me. I don't really care about you.
Plus y. No, let's do 2y.
Ooh,
Right.
wow.
Oh, wait. Hold on. I'm ready.
What? Okay. Plus the.
This is harder. I gotta, make sure I don't lose my hat because I'm gonna go fast.
Okay.
You gotta go fast.
I'm a little funnier than the banner thing.
Minus 3y prime. Or equals cosine x.
Okay, and so the function is y equals a sine plus b cosine. Is that the correct function you would like me to use?
Sure.
You tell me.
Yes.
Yes. Okay. Y prime is equal to a cosine minus b sine. Y double prime is going to be negative a sine minus b cosine. This differential equation he gave me says the second derivative, that's negative a sine minus b cosine, plus twice the original, I think, 2a sine plus 2b cosine. And then you're saying to do minus 3 times the y prime, that's a minus 3a cosine plus a 3b sine. When I combine all that together, I got an equal cosine. So I'm going to try to combine some stuff together. Look for all the sine stuff and put it together. So I see a negative a with a sine in it, I see a plus 2a that has a sign in it, and I see a plus 3b. Those all have the signs. Look at the cosine stuff. There's a negative b, there's a plus 2b, and there's a minus 3a. Those all have the cosines in it. On the other side of the equation, I actually have no signs to deal with, but I do have a 1 cosine. So what you've told me here is that a plus 3b has to equal 0. That's the top stuff. And you've given me that negative 3a plus a single b has to equal 1. If I multiply the top by 3, keep the bottom the same, I'll get 10b is 1, and b is a 10th. I feel like we got this before.
He did it by sure.
Turns out a plus 3 tenths has to equal 0. A is negative 3 tenths. Done with that one. Go. Number what? 2.
Oh.
Number 2.
F of x equals x minus 3x
I did it.
square root of x. 3x.
F of x equals
X minus 3x square root of x over square root of x. And differentiate.
So this is still f of x. I used something called the distributive property. This is still f of x. I used the fact that there's this thing called cancellation, as well as properties of exponents. And then I finally found my derivative. And then I did this thing that Jay was asking about, and I didn't want to go back to radicals. But you could write 1 over 2 squared of x. This case, not so much, but the other case, yes. You could also use quotient rule. Well, why would you use quotient rule?
It asks you to use.
I know it does, but why would you do that? Because if you do quotient rule, you also have to do product rule. I mean, that's like saying, hey, let's try it all real quickly by hand. Multiply 13 times 17 by doing repetitive addition. 13 plus 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 13. No, it is. I mean, yes, but it's dumb. So, I like that problem as a homework problem, aren't you? I don't like it as a test problem because the point of it is to make you think about stuff, and that's supposed to be done by the time a test is happening. Tests aren't really about thinking; it's about showing you've done or you've done your thinking. But,
Will the test ever ask you to like use a specific rule?
yes. Like the last test you took said use the definition of a derivative to this. This is wrong.
3545.
3545.
Let h be differentiable on 0 inclusive to infinity, and define g by g of x equals h of square root of x.
Like that?
Yeah. And then where is g differentiable, and b find the expression for g prime of x.
Okay. I would think g prime would be h prime of square root of x times the derivative of square root of x. Right? Now, Jay, this is one of the reasons we do like to change the format, because right here it's not as obvious what the answer is, but if you change what g prime is, it's a little more obvious where things become a problem. It's not differentiable at 0. Because this is undefined at 0. If you put 0 in, you got a problem. Up here, people might think, oh, you put 0 in, because 0 to an exponent is okay. But then down here it's a little more obvious, you can't divide by 0. So g prime of 0 is undefined. So you'd say that the derivative of t doesn't exist at 0, so it's non-differentiable at 0. Yeah.
3, 5,
22? Go ahead.
the fourth root of
Let's do it. Did you do it?
All over the fourth root.
What? No.
Q plus 1 divided by,
t cubed minus
okay.
and find the derivative.
Is this a y equals or anything?
S
S of t? And then want to find s prime? Okay, so that's going to be 1/4 this stuff to the negative 3/4. You okay with that first move? Okay. We have a t cubed plus 1 over t cubed minus 1. Now I have to take a derivative of the thing inside, which means I'm going to use quotient rule, which is going to look like this. Hope d high minus high d ho all over ho ho. Alright. S prime of t is 1/4 of t cubed plus 1 to the negative 3/4 power over t cubed minus 1 to the negative 3/4 power. You might be asking yourself, hey self, why did he change the notation from here to here? You'll see, maybe. I don't know if it's going to do anything or not. Okay, now I got to work on the top a little bit. If I distribute the 3t squared through, I'll get 3t to the 5th minus the 3t squared. If I distribute that 3t squared through, I'll get a minus 3t to the 5th and a minus 3t squared, which is easy to screw up puppy was. I think I did it right. So simplification, which I think I pronounced wrong there, of the top of that stuff. Let's see here, we're going to get a t cubed plus 1 to the 3/4 and a t cubed minus 1 to the 3/4. I still have no idea if that's actually going to do anything. I have no idea if this was a good idea or a bad idea. I'm just starting to, if I have to write it down, I might as well write it down and another step. Over here, there's a 3t5, 3t5 that cancels, and there's a minus 3t squared and a minus 3t squared, which becomes a minus 6t squared. On the bottom, I have a t3 minus 1 squared. And now, I'm really glad I did the stuff I did over here. So I changed the notation kind of slightly over time. Now I have like terms here. I'm going to combine those like terms. That's why I did what I did. So this is 3/4. That's 2. 2, sometimes known as 8/4. So if you have 3/4 on the top and 8/4 on the bottom, I'm kind of thinking that makes a 5/4. T cubed plus 1 to the 3/4 doesn't have any like terms. I'm going to leave that alone. There's a 4, but there's also a 6. Now I have to ask myself, hey self, should I keep going? Rationalizing wise, I mean, I could multiply this thing, exponent of 1/4 top, 1/4 bottom, and this one over here I would do 3/4 top, 3/4 bottom, but there's no need to do that. You don't need to rationalize variables. I don't see anything else I would do here. I would stop. I believe that is simplified with reason. The question is, if this was a test question and I was trying to grade people, where would I start taking points off of? If you left your answer like this, I would absolutely 100% take points off. There are things to combine, and those things once combined, canceled out really nicely, agreed? You also see how the 6 and the 4 cancel to make a 3 and 2. I'd be looking for that. The thing I would have to debate with myself is, should I cancel or take away points for people that didn't reduce this? Well, here's the thing. Some people will see a 3/4 and an 8/4 and cancel it incorrectly. They'll try to combine them together, but instead of subtracting to getting 5/4, they'll try to like I don't know, divide them on, like, they'll try to, like this. I've seen this kind of thing before.